Hi everyone, welcome to Dcademy mathematics class. In the previous classes, we have already started this exercise 1.2 up to question number 5. Today, we will proceed the next question. Pag mamangi classes ta na exercise 1 hokre or chapter pagi real numbers, pagi magi different topics, terms mayam ama khangdaba yadaba important terms mayam ama koi gyan taminegre ko ado ngasi makha chatharko oina koi exercise 1.2 gi question number 6 torsi question number 5 se koina aina mamangi da togi drabane adugo question number 5 se ai noi the hints matema pige question number 5 se koina kamai to give the check whether 6 to the power n can end with a digit 0 for any natural number n haibane ko question number 5 se noi ne gyan ta da so adum to bi ai ko kisu kai de then question number 5 se yawi se 6 to the power n karigumba n hari base natural number oiba taragadi 6 to the power n se mase kuna factorize toroba matungda magi tarakpa magi multiplication gi magi result to 0 taroen haibane ba 0 ta hingin harigadi kamai to gadage 0 tagadra taroidra check to haibane natra adu targadi 5 first ta 0 ending oiba machine khudimak se koina 5 na divide to ba yabra yai ko 5 na divide to ba yai suppose 100 200 had to say 200 se 5 na divide to ba yai 615 had to say 650 5 na divide to ba yai natra 5 na divide to ba ya badi either koigi 5 ending natraga 0 ending oibane natra adu targadi sida hangi bu question sidi 0 na loiba machine oibra ina haibane adu targadi 6 na hari se karino hari gadi factorize prime factorization torgana 6 habi 2 ga 3 ga ne kan dai ko adu targadi 2 ga 3 ga 5 na divide to ba yar ba adu 2 ga 3 ga se 5 na divide to ba yar 5 is not the factor of 6 adu na maram oidina pyramid 6 to the power n for any natural number n sina n si value se 6 to the power se koina 5 oisanu 10 oisanu 13 oisanu 3 oisanu ko any natural number oiba matamda magi 0 ending gi oiraroi haiba ko karigino harigadi masi 6 haribase factorize torba prime factorization torba 2 into 3 ni which is not divisible by 5 therefore it cannot end with the 0 yare ko next question tokshi question number we give 5 tokshi ko question number 6 tokshi question number 6 ta hari se explain why 7 into 11 into 13 plus 13 and 7 into 6 into 5 into 4 into 3 into 2 into 1 plus 5 are composite numbers mamangi da koina mamangi classes ta ina explain to gore composite number e kadai bu ko ke hai ba composite number harigadi karino harigadi if a number having more than 2 factors factor ani degi hena laiba taragadi madugi number do kai kaure composite number kaure example 6 haribasi composite number ra mani 6 ki magi factorize tor matungda 1 into 6 1 se prime factorization of 6 are 1 2 3 and the 6 itself let's draw the 6 composite number na habi 5 is a composite number ra no because 5 has only 2 common factors 1 ga 5 masamag adu targadi 4 habi composite number ra mani kamaina 1 ne 2 ne 4 ne ani dig henta hele ko adu sidi yengasi question number 6 now in hybidamoko now in irony 7 into 11 into 13 in 11 into 13 plus 13 si ani si ke koina tam ani khak lai 7 into 11 into 13 is a tam amani ko atopa tam this is a tam sisu tam ani chiri ge koi ne kari kamal lo ya ge have 13 je kamal lo ya ahama tam de 13 kamal lo tar ga di 7 into 11 tare ani suba tam de 13 lo tar ga di 1 le ho re ko 13 ni 13 lo de 1 le ho draw ji 13 into 7 into 11 is 77 plus 1 77 plus 1 is kya no 78 tare ko 13 into 78 ado 13 into 78 kya tarage 13 into 78 1014 1014 asingmadi masigi 1014 and haibigi mahutta okay keno ma hairsi ko 78 si factorize tarosi yam lai bi method ma haire ke ko 13 in hairo 78 haibisi factorize tarosi kamai taroni 2 3 za 2 6 za 2 1 za 2 1 za 2 70 ni hum taru ni pam tran 3 1 za 3 3 3 za sini kya tarage 2 into 3 into 13 haibidi kaino hargadi 13 square into 2 into 3 target masi composite number oiribra ko haibidi haiba masing singe composite number ge form da sado pui bani ba pento ise hence set ko mathangi dina man karamano 7 into 6 into 5 into 4 into 3 into 2 into 1 plus 5 masagi mamangi adumaina koi kamai toroni 5 se ani makte yaurabni na kamal lawr siko tam ani ni lady siko 5 se kamal law matumda 7 into 6 into 4 into 3 into 2 plus 1 and irony 5 into 6 atare manungi se 3 into 2 6 6 you are 36 36 into 28 36 into 28 kya tayo di 36 into 28 36 into 28 di si multiply to si ko then masigi se 1008 tare ko 1008 tare 1008 plus 1 1008 plus 1 di kya no 5 into 1009 1008 plus 1 1009 tare 1009 sida koina kaya na divide to yagi 7 into 6 into 4 into 3 into 2 plus 1 and then 1009 into 5 1009 haribase prime number ni prime number ga uji 5 amaga multiply torobani na which is a composite number haramani ko adum harambi ai which is a composite number chise dum haibim no asma harambi are ko which is a composite number hence said. Can I go? Next, or see, next question number 7. Question number 7 there is a circular path. There is a circular path around a sports field. Sonia takes 18 minutes to drive one round of the field, while Ravi takes 12 minutes for the same. Suppose they both start at the same point and at the same time and go in the same direction. After how many minutes will they meet again at the starting point? Circular sports field amagi circular path ama ikoi koiba magi lambi magi path ama ka leibasida Sonia na akoi biduda managa round win mana sien ma matam sida 18 minutes change aduga Rabi na mu hariba sammanaba jaga dagi sammanaba habiti circular path sida koiba matam da 12 minutes change adu itargadi hariba Rabi hari siga Sonia hari siga sammanaba starting point dagi makoina same direction da makoina same time da karigumba koina satma matam da karamba matam da makoini unagadage at what time how many minutes minute kya lairaga will they meet again at the starting point du unagadage in haibane adu targadi same direction satpa oirabanina mase koina LCM lawrani LCM of 18 minutes amasung 12 minutes ki LCM lawrani ko se ko yeng asi time taken by Sonia to dive one round of the circular field. Kano Sonia gina kano 18 minutes. Time taken by Ravi. To dive the same field. Kano Ravi gidi 12 minutes. When both of them start in the same direction at the same point and go in the same direction. Time taken in which they meet at the starting point. Is equal to LCM. LCM of 18 and 12. 18 กับ 12 คือ LCM จะ lower นี่มันเป็นอะไร 18 minutes and 12 minutes. Adu tadi क्या तारा के LCM of 18 กับ 12 plus क्या तारा ये ngasih? minutes. When both of them start at the same point and go in the same direction, time taken in which they meet at the starting point will be the LCM of 18 minutes and 12 minutes. Adu tadi kaya tadi LCM of 18 and 12 ti sana LCM lo record. Juga masih 2 into 2 into 3 into 3. Kaya tadi di 36 minutes tadi. Yan tara bro? Siluay. Okay. Jadi kau na sigi exercise cuma dia kau na complete way record. Matang di exercise, kau exercise 1.3 before we start this 1.3. First of all, kau na mamang gusto ko rational number, sini irrational number type. Irrational number ni na kau na prove to ko ni sida hai siko. Ade masih kau na rational number haragadi koi definitions mamang pi gre rational number kadai bo koge which are in the form of p by q ki form the thambaya ba q is not equal to 0 p and q are integers mamang to gre ko sana aduna q se koi gi 0 ga mana ba ya draga ya da ba habi meaning di kari gumba q is 0 ba taragadi that the number will be undefined ta beni adun masin madun ko rational number ni irrational number ke example kar pu harigadi irrational number di pi haribase irrational number non repeating non terminating chu oigadaba non repeating decimal expansion chu oigadaba ko mamang ko ne togre adun hosigi root over 2 in harise irrational number ni adu proof to irrational number ni proof to haritu ni sigi exercise ko adigi pi ki value se 22 by 7 and a half Hariga sumasigi pi haribas magi value se sukimatik sangre yam sangre ko which is not repeating repeat to the masing mayam punsan la kar same ni pi value se ko aduga kogi decimal expansion ma le men khale decimal expansion haibadi non recurring suppose 1 see the 3 in a divide to matamda 0.33333 masi koina irrational number ne haibiyat masi rational number ko adu irrational number haibadi root 2 obi ai pi gi value obi ai aduga 0. Suppose 5.101001000 sana 0 masing henggal sing masing irrational number sing ko yang asi exercise 1.3 exercise 1.3 question number 1 here we say prove that root 5 is irrational root 5 is irrational ko yang asi ahanbada masi root 5 se koina rational number ni na koina han lowran tar kamai hairani let us assume to the contrary that root 5 is rational. Masi magi rational in hierarchy. Kamai toni rational hierarchy p by q ki monda p by q hierarchy a by b a ga b ga si integers a by b ki form da le draw. B is not equal to 0 in my hierarchy masiko. Suppose we can find integers a and b, a and b. B hierarchy b not equal to 0. B is 0 ka mana badi adi na haram tare ko. Such that root 5 siga kari ga manare a by b ga manare lore. Root 5 siga a by b ga manare lo adu tari a ga b ga si kari tare masi co prime tare. Hypody a by b in hierarchy a ga b ga si common factor not other than a and b. Sana haram masi. Suppose a and b have a common factor other than 1. She item the shui common factor other than 1. Adu tari kaya tarake. 1 dagi henna common factor later but dubu ko na masu ad masigi ani si kari ko again. Adubu masi ko na a ga b ga divide tong na ba matamda a ga b ga si co prime ni haram shui ko a ga b ga si co prime ni other than 1 haram si common factor other than 1 and a b are co prime. A ga b ga si co prime ni ko. A and B are co prime. The target is squaring both sides or siko. Now squaring both sides. Squaring both sides we have root 5p squared kya target root 5p squared 5 tar niko. Root 5 whole square is equal to a by b whole square. Root 5 squared kya no 5 tare shina a squared by b squared. Amane a squared by b squared hareko. The target is 5 b square is equal to a square height. Adu target is a is a common factor of b. A is the common. A is divisible. Root 5 is divisible by kay harni. A square is divisible by 5. Aduga a is divisible by 5. Natra. A square is divisible by 5 harani. Aduga a is also divisible by 5. 5 na ani mutta divide to yare. Ko. So a square is divisible by 5. A is divisible by 5. A square to 5 na divide to yara banina. A to 5 na divide to badum yara niko. Sima koi khangjalo. So we can write therefore then and hybidamo ꯑꯩꯈꯣꯏꯅ A ꯍꯥꯏꯕꯁꯤꯒꯤ ꯃꯍꯨꯠꯇ ꯑꯇꯣꯞꯄ ꯃꯁꯤꯡ ꯑꯃ A ꯒ ꯀꯔꯤꯒ ꯃꯥꯟꯅꯔꯅꯤ ꯍꯥꯏꯕꯗꯤ 5C ꯅ ꯑꯇꯣꯞꯄ ꯑꯅꯧꯕ integers ꯑꯃ ꯍꯥꯞꯆꯜꯂꯁꯤ. Now then A is equal to 5C for some integer C. For some integer C 하이시고. ꯑꯗꯨ ꯇꯥꯔꯗꯤ ꯉꯁꯥꯏꯒꯤ A ꯒꯤ ꯚꯦꯂꯨꯗꯨ ꯀꯣ ꯁꯤꯟꯖꯜꯂꯁꯤ. A ꯒꯤ ꯚꯦꯂꯨꯗꯨ ꯀꯌꯥꯅꯣ ꯍꯥꯏꯅ ꯍꯥꯏꯔꯒꯗꯤ A ꯍꯥꯏꯕꯗꯤ ꯀꯩꯅꯣ 3B square. A square ꯍꯥꯏꯕꯗꯤ sorry 5B square. ꯅꯠꯇ꯭ꯔꯣ? A ꯒꯤ ꯚꯦꯂꯨꯁꯦ substitute ꯇꯧꯔꯁꯤ. Squaring both sides ꯇꯧꯔꯣꯀꯣ. Squaring both sides. Itu kya tarage? A square is equal to 5C whole square. Di kya no? 5C whole square. Squaring both sides over C. 5C whole square di 25C square tar. A square is equal to 25C square tar. Substituting A square is equal to A square value do kya no? Mamang ide A square value is equal to A square is equal to 5B square happening ko. We have. Aduna kedorani se A square mo ta kana 5B square happirani. 5B square is equal to 25C square. 5B square is equal to 25C square. Natra. So targeti B square is equal to 25C square by 5 makada lao 5 have 25 tareba natra. Aduna B square is equal to 5C square. Adu targeti asagi mamangida koina mo A square ga 5B square ga manabada A square is divisible by 5 haibneba. Adu huji B square laani sorry C square. A square divisible by 5 huji B square also divisible by 5 hai. B square divisible by 5. B divisible by 5. Hoje akhoi na tawise kamai tawge da B se A su B su 5 na divide tawbu yare na haibu sagi akhoi na assume tawbu du madu lalani adu taragadi natra. Ama khatanga divide tawbu yagadabani. Ani manga divide tawbu ya taragadi mase akhoi na prime number ne hairado co prime ne hairaroi haigadro hairaro. Therefore A and B have at least A and B have at least 5 is a common factor. Common factor. This contradiction facts that A and B are co-prime. And it masi contradiction se assumption la na lo bugine ko. It is arisen It is arisen from our wrong assumption. That root 5 is rational. Hence proof. We conclude that root 5 is irrational. Aduna root 5 se irrational number ni na ko ni conclude tawre. Yan tabre yung ko. Yang si matang Basically, question number 1 se khangagadi question number 2 adugi lemhoriba question si loina hotpa yare. Samana question ngata ni ko. Haibadi question number 2 dia we say prove that 3 plus 2 root 5 is irrational heaven. Sir tamani khag yaro me. Tamani yaw sigi di ke dawra ne koina. Ahan bada 2 root 5 se han irrational number ne lawran. Karigumba irrational number amaga rational number amaga sum up to matam na koi result to sudumi irrational number tani taro draw aduna masima ko ni irrational number na haidu aduna si ko ni samjalaga hotpa yani ko yenga si question number 2 se adum ai sida adum holamage ko question number 2 prove that three plus 2 root 5 is irrational. Yenga si masi irrational number ni na ko na prove to ni ba ko sumi yenga na si ko. Sana mamang ito man nasi santara masi solution. Let us assume to the contrary that 3 plus 2 root 5 is rational. See if the rational number in lower say that is we can find co-prime sing we can find out the co-prime A and B ko A ga B ga C co-prime in lower shape ta aduga B sina not equal to 0 sorry it's not equal to 0 harang madam ni ko sumaina such that no target is say 3 plus 2 root 5 in hari se siga kari ga mana to no A by B ga mana halase ko A by B ga mana halase adu target di masi ko na kamay lakari ham tumta so nakadala ni 2 root 5 is equal to A by B minus 3 na lang draw so nakadala thang masay to pubiro ko right thang masay to pure do target di any number at the dividing both side 2 root 5 city kari 2 root 5 si irrational number ni na koi nam mamangda root 5 ama yauri binina any number which is multiplied with the irrational number with the number itself then the result will be irrational number tani bako This contradicts facts that seeing as LCM law 2 root 5 a minus 3b by b root 5 is equal to Shigi 2 Simakata law a minus 3b by kya 2b. Okay. See, a and b is integers in high record. Since a and b are integers, we can get it here. A and b is integers. We are going to a minus 3b by 2b in high rational number. Lower draw. Rational number ani ki magi ratio sing do sorry integers ki magi ratio sing do rational number fractions yan tai ko retargeti since a and b integers, we get a minus 3b by 2b. That's all. A minus 3b by 2b. Masi chu kay where ni? Masi rational number tayo ni. AB by a by b minus 3. A minus 3b by 2b. A minus 3b by 2b is rational. And so root 5, masagi root 5 is irrational. Sorry, root 5 is rational. Root 5 is rational number. But this contradicts facts that root 5 is irrational. Masi irrational ne na koina hana khangrabane adubu masi koina rational number tahle natra. This contradiction has arisen. This contradiction has arisen. Try de lakpo no? Because of our incorrect assumption, wrong assumption that karino 3 plus 2 root 5 is rational. 3 plus 2 root 5 is rational. So when rational ne hana low good. Natra. So we conclude that we conclude that 3 plus 2 root 5 is irrational. Hence, true. Yan tari ko. Sumaina, rational number ni na kuna hana assume tawro. Tawro ba matung na last na masigis may irrational number tara ba matung na masig kuna wrong assumption lag padagi masi conclude tawri madudi masi irrational number ni haigada ko ado hujiki hariba sigi exercise same exercise with exercise 1.3 gida lairiba question number 3 da yawi sijin adum samanare haibadi hujiki 1 by root 2 1 by root 2 se masi se prove that masi irrational number ni ne prove tawin haibani ko hujiki du siga adum samanare haibadi root 2 se kamai to ge matam da koina rational number ni lowduine 1 by root 2 se any rational number amaga irrational number amaga divide tong namu matam da the result will be irrational number takani root over yaw utaragadi ko aduna sina takpade koina rational number irrational number haibase koina assumption to buda koina masiam laina kan to buyai ko yengasi uji adunu ji exercise 1.3 loire ko exercise 1.3 loire duga exercise 1.4 exercise 1.4 se mati mi yengasi exercise 1.4 se holding gi mamang da sige exercise 1.4 se holding gi mamang da koina ko theorem ama khak yamna marui ba theorem ama khak koina yengsi ko hai ba theorem se karino ya harigadi theorem se amana theorem 1.5 adigi amana theorem 1.6 and theorem 1.7 hai ba theorem ahum se kogi exam du budi am toina masi hangba ko keno dinate adu masi it is applicable for this exercise 1.4 exercise 1.4 masi apply torokan da hot kadaba yauri ko yengsi yengminersi theorem 1.5 te yauri se koina kamai hage abda let x be the irrational number ni lower siko magi decimal expansion se terminating hoy terminating decimal expansion oirakanda x can be expressed in the form of p by q form the expressed to yai hai ko ado where p and q are co-prime moiduni ko p and q are co-prime and the prime factorization the q factorization of q is of the form of 2 q by the denominator fraction number level to the makha thang mut saruk te leido ko denominator ko we mathaki dina numerator ko kangre ko the q se kari form da la ko ya ga da ge har ga di 2 to the power n aduga 5 to the power m for any natural numbers non negative integers hoy m ga n ga se non negative integers hoy 2 ga 5 ki magi factorize magi prime factorization ko kita bana have one suppose my example ma hai wa har ga di denominators na kari gumba suppose machine ma har si ko 657 sida koina 4 na divide to matam terminate to ba decimal expansion da terminating decimal oigetra non terminating haibadi loiba khamban nai dena divide to ya ba dum divide to ga dum leiba suppose 1 sida 3 na divide to matam da 0.33333 masi ko non terminating ko kariguma 1 si 2 na divide to ta ga di 0.5 natra ad machine ko terminating ko kay do bagi 0.5 na lai terminating ka main khang doi no machine jem saura ga di koi khang roi machine je saura ga denominator de liba machine je depend to have one denominator de liba machine se in the form of 2 to the power n 5 to the power m in hagada adu tar ga di machine 4 have di kai no 2 with the 2 to the power kano 2 657 sidanga sagi 2 to the power m 5 to the power n have neba aduga n ge m ga sida mana ga manadu du ya sida power se n se kya target 2 tar adu target into 5 to the power 2 mathak su makha su multiply to option min kya tar se makha gi se 2 into 5 to the power 2 power kam lo wi ai mathak gi sum thabire mani 6 5 7 into 5 into 5 25 natra Maka is kya tar kya 2 5 जा 10 10 square tar अपना तो मथा कितना 6 5 7 into 25 maka da kya la ni 100 la adu tar के point je san तो ले ba machine ले ba मैम सिंग point na ma ni ba tra machi bu ke ko re terminating decimal expansion adun machine ma pira ma tam da terminating oibra oidibra na hai ba do machi gi theorem sigi mating ni yam lai na khang ngam ko ya tar ko Matang. Theorem 1.6 there we say 1.6 there we say let x is equal to p by q model be the rational number ne lower say x such that the prime factorization of q denominator ki q do it is of the form of 2 to the power n 5 to the power m where n m are the non-negative integers. Then x has a decimal expansion which terminate. Because you do someone. But I get p cube the prime number or big wari ni. Ko. Adu taragati she na mu kamai to have the terminating decimal expansion. Theorem 1.5 to 1.6 because someone about come the prime number or co prime. Next. Theorem 1.7. Let x is equal to p by q be a rational number such that prime factorization of q it is not in the form of 2 to the power n 5 to the power m. 2 to the power n ga 5 to the power m the form the karigumba magi denominator q shall lerim the targadi non-negative integers ne m n lisna. Then x has a decimal expansion which is non-terminating organism. Vice versa, theorem 1.5 to just vice versa. Repeating hypody non-terminating or repeating or repeating having meaning the recurring in a blood. Recurring is some meaning. Exercise 1.4. Sidigi question number nikatang tausi tawba matungda. Point again tani ko. Question number 1. Question number 1 gi Roman number 2 hai rasi ko loina mang to daswi ani Roman number 2 question khar khangala tawni ko 17 by 8 17 by 8 in the pyramid by 17 by 8 se ko denominator se p by q ki form the denominator se 8 ni ko now in hybinama 17 by 8 hybig meaning the 8 hybig kaino 2 to the power 3 ko mathang step ta 5 to the power m ga 5 to the power 2 to the power m 5 to the power 2 to the power n 5 to the power m hybig ko adu targadi masi mathak sumakha su masi koina kamai to ge hematamda 5 ti wali denominator se 2 to the power 3 lere 5 to the power 3 hapsan mam darkar leitro leiko dare na kan nam khat denominator kata hape ade hapsan libe se mathak chu hap kada samana ma machine mathak chu makha su multiply to 5 cube na mathak chu makha su multiply to ko bitare ke tare se makha de pili be se 2 into 5 to the power 3 17 into 125 10 cube अच्छा किसने क्या आता है 125 into 17 है ना तो 125 into 17 नहीं क्या आता है 2125 2125 चीज क्या आता है नहीं मखा तो 0 ओम नहीं रे divide to matam da 2.125 aduna without actual performing the long division direct sang divide to not the bida magi se makha de piri basing se non terminating oigadra terminating oigadra haibi one ko which is a terminating decimals natra, which is a terminating decimal. Asingmadi masi when divide tawdrega su makhagi se 2 to the power m ga n ga 5 to the power m ga ani gi marakta ani gi form de leirabani na masi terminating decimal ni expansion ni na haram yabudi yare ko se magi division method ko changa divide to natte bi non terminating ni habin singo mayam loina semba yare ko aduna siga samana na hojiki mathak makha de piri bu mayam sing suppose roman number 7 ni yaw isi roman number 7 ni yaw isi ate mayam sing samana ba ngatani roman number 7 no mu yeng si ko question number 1 gi roman number 7 roman number 7 ni yaw isi 129 by 2 to the power kano 2 5 to the power 7 7 to the power 5 adoi makha da lei ba sing se 7 habam yaw 2 ga 5 ka lei magadi yare fare denominator su 2 shi da ko 7 habam yaw 7 se ma se it is not the form of 7 yaw bu da maram poidana divisor 7 yaw ra ga di ma se ko ne kai ko e ma remainder mayam am la ni aduna ma se kai wani non-terminating decimal expansion koi ni in haram ko so haram si now the denominator two to the power 2 5 to the power 7 7 to the power 5 are not in the form 2 to the power n 5 to the power m which has a decimal expansion of non-terminating repeating aduna masigi pirami basi masin non-terminating oini ba ko therefore it is a non-terminating habidam it is a non-terminating repeating decimal therefore it is a non-terminating repeating decimals harmony ko samane ate mayam sing si na you can do it by yourself ko sikai be mayam sing se the next question number sigi question number 2 write down the decimal expansion of those rational number question number 1 matuk pi basing se which has terminating decimal expansion oi basing se rational number ki form do ni expand to have ni ko write down the decimal expansion for makha de pi ba rational number sing se decimal expansion oi you in have ne ba have di magi non terminating have the natab decimal do one expand to kan oi you have ko mai kari kumba yengasi adena hojiki hariba question number 2 de awchina kaino habidi mamang de pi ba question number 1 se suppose 13 divided by kya have no 3125 have ne 13 see the 3125 ne divide to in khalis 31 say appoina with the help of the calculator ma say appoina hot matam the 0.00416 time Basi kamay to get yam easy way da yam live method da. Basi ki mamang da hai gre. Decimal expansion question number 1 gida. Question number 1 gida kamay hai gi. Mamang gi se magi denominator lay ba mayam sing se. Non-terminating oigadra, terminating oigadra na hai basi makha da p ba denominator du da. Basi theorem 1.5 ki matungina. 2 to the power n 5 to the power m the form the labor target the mathakti p ba mayam sin decimal expansion oigani in haibane nata aduna hojiki haiba mayam sin adugi form da han sado aba matung da non terminating sado pa sing je koina mu long division tawrani sado pa yada ba sing du di ko sado pa ya ba sing du na kamai to ni haraga di decimal expansion do yam live mo easy way to ko si to dra siya ko aduna question number 3 to che question number 3 is there always kari no hai ge the following real numbers has a decimal expansion is given below the target the prime factor of q kya wo duna hai ba mai ge q mai ge factors q ge forms kya wo duna ji ke hai ba se pyramid se koina now I know class 9 is over ko real number khar pyramid decimal expansion khar pyramid makha de p ba mayam sing che koina decide the way whether they are rational number or not rational number haragadi non repeating non terminating chu oigani non repeating chu oigani ba mase adu tar di karam mase koina mase koin irrational number ni haidino mase mase koin makha de p bise rational number ngata ne khallasi the target amana terminating oigani adu gojiki Roman number 2 question number 3 ki Roman number 2 sida kamai to get da masi Roman number 2 sida kaino yaw se masi rational number natte irrational number ni hai shi Roman number 1 sida kamai lai no hargadi prime factorization q se either 2 or 5 natraga both anima haideni ko jike kari gino hargadi 43.123456789 natra point man ge liba singje adu q se kamai daga abidi pq ki form da thamoi na hargadi we can say that prime factor of q se kamai like kamai na like da ki haibne ba ko aduna sigumba decimal expansion sing se koina mo kamai to ge ha matam di remainder sing firstly koina ko ji mamange theorem 1.6 da koina kai hagi ge haiba matam da theorem 1.6 da yaw se x haiba c p by q ki form da leiba targa di rational number ne logo targa di masi prime factorization method q da q se 2 to the power m 5 to the power m ge form da non negative oge da mn sina ko adu targa di x se decimal expansion da terminate oin haiba ne adu theorem 1.7 da na non terminate oin haiba ne adun masi terminating decimal oirabanina question number 3 gi Roman number 1 so terminating decimal oirabanina theorem 1.6 se apply tawrani aduga question number 3 gi Roman number 3 sina mu recurring haibadi repeating ne masina kaino non terminating theorem 1.7 to pan kada aduna hairiba sing se bagi apply tawraba matung da masariba theorem sing je apply tawraba matung da mase ko papiya ko okay anyway asigidi matam si losinabina next class ta mo na siko thank you